Hello, everyone. Thank you for joining us for today's discussion on 2D fast mapping for fire and emergency response. My name is Mark Flam, and I'm the Enterprise Sales and Support Manager here at DSLRPros. I'm happy to introduce today's panelists. Joining us from Pix4D is Angad Singh. Angad, you there? You want to tell us a little bit about yourself?
Yeah, absolutely. Thanks, Mark. My name's Angad Singh. I'm a business development executive at Pix4D. Manage public safety for North America for the company, and pretty much just consider myself like a drone guy, remote sensing guy that really likes drones and really feels passionate about helping public safety understand how these tools can be utilized, and then making sure that we build good tools for themselves. So anyway, Mark, thank you so much for having me on this webinar today. I really appreciate it.
No problem, Angad. Thanks for joining us. Also joining us is active firefighter Derek Ward. Derek, you there? Would you like to introduce yourself?
Yeah, thanks, Mark. My name is Derek Ward, the Director of Public Safety for Enterprise UAS. I'm also a commercial drone pilot, and I have 31 years of active service with the fire department, one of the largest fire departments in the US, and also a co-lead pilot. Great to be here with Mark. By the way, I wanted to say it's great to be here with Mark and Angad talking about some of the latest mapping technologies.
Awesome. Thanks, Derek. Yeah, and I've had the chance to work with both Angad and Derek on multiple projects over the years, and I can say between the two of them, there is a massive wealth of drone mapping, public safety, and all sorts of knowledge between the two of them. So thank you both for joining us. And again, my name is Mark Flam. I'm the Enterprise Sales and Support Manager at DSLRPros. Today's webinar is hosted by DSLRPros and is featuring Pix4D. Before we get into the details, Angad, can you let us know exactly what is Pix4Dreact?
Yeah, absolutely. I think we'll go through the product, through the process of the webinar here, and I think the focus is going to be more on the applications and how it can actually be utilized rather than the product itself, because it's more important to see how that tool is important and why it's a powerful tool. But the reason I think why we're here is to learn about, learn about Pix4D technology or mapping technology with drones for firefighters. And really quickly, before we get into all this, I think that we wanted to learn a little bit about why do we care about maps to begin with? Well, have you ever heard that term that a picture means 1,000 words? Well, when you're communicating logistics post-event or pre-event, you don't want different folks on your team to think about 1,000 different things. You want them to get one thing, one piece of information communicated. And with a picture, there's inherently perspective. Like if we're looking at the screen right now, and you can see the picture of that of this overturned tanker truck here with fire trucks around it responding to the scene. If you gave that picture to somebody, they would understand what's happening on the ground. But if you gave them an aerial map from the top where actual photogrammetry algorithms have been applied to all these images, then you can make accurate measurements and you can display precisely what that scene looks like from the top end. And it's a very powerful communication tool. It's a very powerful tool for preserving digital evidence. And quite frankly, maps have been important for eons. I mean, we've been using maps to explore, to get to the new world, and now with drones, we're really giving people the capability to make maps, very accurate, detailed maps on their own computers. And I think that's really powerful for this industry. And that's why we're here to talk about those applications with Derek today.
Yeah, that's a great point, Angad. Just using a single photo, you can't take measurements. It's only when you have combined multiple photos that you can use the art of photogrammetry to take measurements off of those photos. So that's a great point there. So before we get into all the details, I'll start off with a real quick introduction about us. Established in 2012, DSLRPros has been assisting police and fire departments and industrial and agricultural service providers to launch and scale their own drone programs. We offer technical support, training classes, repair services, and wholesale distribution. We're an authorized Pix4D, FLIR, DJI, MicaSense, and SenseFlight partner located here in Southern California. We work with large federal and state level organizations all the way down to the one-man survey shops. So if you're thinking about starting or scaling a drone program, give us a call, we can help you out. And then just a couple of quick notes about today's webinar. This webinar is being recorded and we will share the recording with all of you. Also, we encourage you to ask questions in the question panel throughout the webinar, and we'll do our best to answer them at the end or via an email. Now we'll take a look at today's agenda. We're going to start off with a quick background on rapid mapping. Then we'll discuss what is Pix4D. Next, we'll take a look at some of the commonly used aircraft, then discuss the various use cases. This is when we'll have a chance to learn how agencies are able to gather real-time intelligence and maximize their resources during a disaster using Pix4Dreact. Then we'll finish off with a good old Q&A. So now I'm going to hand it over to Angad to introduce Pix4Dreact.
Absolutely. Thanks, Mark. So here we're going to give this general corporate slide, and I think there's a reason that I think this is actually important. And it's actually important because the story of the company is that Pix4D as a firm has been around for about 10 years. Our headquarters are in Lausanne, Switzerland, which is in the center of the map here, identified by that green little arrow, rather than the rest of our satellite offices that are through the rest of the world. And in North America, we're based out of Denver. That's our headquarters. And the reason that this is important is because we've grown to some 55,000 active users and 200 plus global employees purely based off sales of the software itself. And I think that's critical for folks to understand because it means that Pix4D as a company is not going everywhere. It demonstrates that we have a dedicated commitment to making sure that the support is top tier, the training is top tier, and that people are treated correctly, and that our customers really do come first. And because of that entity and the fact that the software itself is very powerful, the company's grown really well in a growing and emerging industry. And over 10 years, we've kind of become a pillar of the software solutions that are provided to the drone industry. And I think that story is important for folks to know because a lot of companies out there are VC funded, which means that they're taking funding in and utilizing that to build their products. Pix4D doesn't operate like that. We operate kind of like more of an old school business where we sell software, we take that money, we reinvest it, and we make more software. And basically, that just means it's a very robust company that's going to be around for hopefully a really long time. And I think for public safety, that's important to know because you're not buying something that is then the company's going to dissolve in a couple of years. And really quickly, let's talk about rapid mapping. Let's talk about, so Pix4Dreact is this product that now is designed for emergency response for the public safety sector. It's what we're going to focus on for the period of this webinar. So the past is that we built Pix4D Mapper. That's our flagship solution, but that's a very complicated engineering tool. It takes a day or two to learn how to utilize. We teach 2-day classes on it. It's very extensively utilized in emergency response today, especially for calculating volumetrics, post-disaster by groups like the Army Corps of Engineers and plenty of other firefighters and fire groups around the world. However, there are some lessons that as an industry, the drone industry learned, especially from the California wildfires, the really bad wildfires that we had in 2017, 2018, and into 2019. And one of the most important things we learned is that the software was not generating the maps fast enough. So with Pix4D Mapper in the past, it took too much time to post-process. You would collect all these, hundreds or thousands of images from a drone, and then when the intelligence was required to be given to the incident commander, it took too long to process that data. You had to have a powerful computer, or you had to wait for all of the images to be uploaded to the cloud so that those maps could be produced. And quite frankly, that wasn't answering the need. That wasn't the right solution for the time. So we took that lesson of, hey, we have this awesome software. We have these awesome maps as deliverables that are really helpful for incident commanders, but it's not being produced fast enough. And so we built Pix4Dreact, and that's where we are today in the present, where we have a software that can close to real time produce accurate maps on a desktop-based computer that's really simple to use in the field. You don't need the internet. You just load all of the images into the software, and it can very quickly, on a simple, regular Windows 10 machine, make these types of maps that provide very accurate, actionable intelligence, locational intelligence for the public safety sector. And so I think that's a big win. It's a big win, and my personal dream is that every drone program in public safety has a copy of Pix4Dreact because, quite frankly, it's such a beautiful solution that it's going to be able to provide a tremendous amount of help. And it's been out there for about 6 months. Plenty of departments have gone ahead and adopted this technology. But we're going to go ahead and we're going to talk about the workflow, and then we'll talk about the actual applications with Derek of utilizing this within the fire protection services. So the Pix4Dreact workflow is 3-step. You got to fly the drone and capture images. Then you have to take the SD card out of the drone, put the images onto your computer, and then process on Pix4Dreact, which is your desktop-based solution. So really quickly, we're just going to talk about Pix4Dreact Capture as an application. This is our free flight planning application that's designed for iOS or Android devices. I will note that it's not required to capture your imagery with our app. If you're comfortable utilizing a third-party application, like for example, a lot of folks like Map Pilot for DJI by a company called Maps Made Easy out of San Diego. If you're using their app, that's fantastic. If you own the DJI Crystal Sky controller, many times running a third-party app like Pix4Dreact Capture on that Crystal Sky controller, it doesn't work as well. So go ahead and use DJI Pilot. That's going to make you the most successful in the field. If you're a department that has gone ahead and is utilizing a solution like DroneSense, then use DroneSense. They have an inbuilt capture app to be able to fly those missions. All you need is the drone to fly a grid mission or a lawnmower pattern where it's capturing a ton of images of the area underneath it, and it's capturing those images at a regular interval. We call that overlap. We want your images to be 70% overlap in the front, 70% overlap on the sides. Basically what that means is if you take any image in your image data set, it'll overlap 70% with the image in front of it, behind it, and to the left and to the right of it. And so as long as you're capturing images clear and in focus, and you're using an app that flies an autonomous mission, grid mission, that's going to be great. And then the drone just lands, you take the images, put them on your Windows 10 device, and you process in Pix4Dreact. And that is the simple workflow that you follow to get this done. Now we're going to go ahead and show you a live processing within the software. So this is a video recording of Pix4Dreact processing. It's not sped up, it's not slowed down. This is real time. You're going to open up the software. This simple interface is going to open. You're going to go down to the right-hand side of the screen. You're going to press the plus button. Now you're going to go ahead and you're going to import your images, and all those images that were collected with the automatic app, the grid mission, will go ahead and load into the screen. Now here, all the images loaded. All we did was press start processing. And now at this stage, it's going ahead, it's loading in the images live, and it's putting them together. The best way to describe kind of how this is working is imagine if you took 100 aerial photographs, you laid them all out on a table, and then you wanted to make one big map or one big mosaic. And these maps are called Ortho Mosaics. Well, you just cut up little tiny pieces of every single photo and glue it all together. That's basically what this software is doing, but very importantly, it's also producing the map with real photogrammetry algorithms, which basically means it's removing perspective in the imagery, which means that it's producing a map that you can make accurate measurements from. And on the screen here, watching the video of the processing live on a desktop-based computer. This was flown about 150 feet with the drone over a 2.5 acre site. It's going to take about 1.5 minutes to process end to end, and it took about 4.5, maybe 5 minutes to fly the drone and actually collect all these images in the field. So I like to use the tagline that this software produces the map faster than it took you to fly. And for most cases, that is going to be the reality, and that really gets us as close to real time as we can get on a desktop-based solution, making it possible so that these maps can be produced and we can go ahead and give that actionable intelligence to folks out there in the field. And now we're going to zoom in, and I want to show you some of the actual inaccuracies of the map, right? So completely honest, this is going to make really, really awesome maps, but because it's working so fast, you have to balance time with quality. And so there's going to be a little bit of like, hey, like that crime scene tape is waving in the wind. It's a little broken. That's okay, because if you want a perfect map, that's what Pix4Dreact Mapper is for. That's what our flagship engineering solution is for. Pix4Dreact here is for emergency response in the field. We have some quick tools, like right there, it just went ahead and selected a GPS coordinate. You can click on anything in the scene, find a coordinate. You can use the measurement tools to go ahead and measure out different areas, see the size of lots, see the perimeter of a burn line. If you're doing special event planning, basically go in and say, hey, how much area do I have in this particular section? How many trucks can I park there? If you're in a disaster response scenario and you need to know how big an opening is between two downed trees or two destructed buildings to see, hey, can I fit a truck through that area? Well, you can go ahead and you can make those simple measurements here on the software, and then you can annotate. So you can annotate all of this. and then you can go ahead and you can export a PDF report that's really easy to share. You can export the full resolution GeoTIFF Ortho Mosaic that can go into third-party systems like Avenza Maps, or it can go into ATAC systems, which is like what the military utilizes, that we're seeing become kind of popular now, or we're starting to see those military applications come into the civilian wildland firefighting sector. And so essentially, we just want to let folks know that all the software we make, all the maps we make, they can go into pretty much any other system, ArcGIS, etc. So with that, that's a real-time demo of the software that shows how simple it is to use. I've given this to firefighters out there that have never used mapping technology before, that have never used software like this, and within 25, 30 minutes, they usually figure it all out. And that was one of the goals, is to make a tool that's super simple. So anyway, thanks for listening to me give that little demo here of how the software works. We want to demonstrate how simple it is to use and how fast it is, and now we want to talk about real content and the applications. So I'm going to turn it back over to Derek and Mark here to kind of talk about what are the popular setups that folks out there in public safety are using today when it comes to drones.
Got it. Thanks, Angad, and thanks for that powerful demo. It's really remarkable how much faster React is than Mapper. We're talking about a matter of minutes instead of a matter of hours. So now we're going to get into some of the commonly used hardware out there for rapid mapping. The great thing about Pix4Dreact is it works with most major manufacturers: DJI, Parrot, Autel, SenseFly, Wingtra, and others. We're going to discuss some of the most common solutions out there now, though. So we all know that the high resolution camera and mechanical shutter on the Phantom 4 Pro has made it a flagship solution for professional surveyors for years. But lately we've seen the Mavic 2 Enterprise Dual become extremely popular with fire departments due to its versatility and low price point. So on that note, I'm excited to announce live on this webinar our brand new public safety rapid mapping package. This is based on the Mavic 2 Enterprise, and it's really like the Swiss Army knife of public safety drones, since it's capable of rapid mapping, thermal imaging, optical imaging, live communication with a loudspeaker, and all sorts of other public safety geared features. So with this package, there's lots of different ways departments are able to deploy their Mavic Enterprise to keep people safe. Basically, DSLRPros set out to create optimized Pix4Dreact solutions around the most commonly used drones in the industry. These packages are designed to be turnkey kits that have all the components needed for a successful mission, like software, monitors, cases, lights, strobes, chargers, all the little stuff, cables, brackets. It's everything you need in a single case, updated, tested, and ready to work. We also offer training if needed. And Derek, I'd love to throw it to you if you have any firsthand experience with any of these solutions, Mavic 2 Pro, Mavic 2 Dual, Phantom 4 Pro, for you to share your thoughts on some of the pros and cons.
Yeah, thanks, Mark. So absolutely have experience on all three of these airframes. So the Mavic 2 Pro and the Mavic 2 Pro Dual Enterprise and the Phantom 4. All these are great solutions, and with the Pix4Dreact to be able to go out and produce a map as quickly as we can now, utilizing these, it's just phenomenal workflow. So the aircrafts are designed to be able to work this technology, and they do a great job doing so.
Nice, thanks, Derek. And if anybody out there is curious as to which aircraft is best for their organization, I encourage you, give us a call, shoot us an email. We can help guide you to choose the right one for your mission. So now that we've talked about the hardware, let's get into some of the fast mapping use cases and learn how agencies are using these exact solutions as force multipliers. Angad, do you want to start us off with some use cases?
Sure, absolutely. So today we're going to talk about three main applications. We're going to talk about wildland fire and forestry protection, and also throw in a couple of real numbers about a controlled burn situation where Pix4Dreact is utilized, and we consider that a win for the industry. Then we're going to talk about search and rescue and how this tool can be utilized within SAR. And then we're going to go into post-disaster response for natural disasters, and following up and understanding what the scene looks like after a storm or after an incident. And we're going to really focus on Derek's experience and how they're utilizing drones in the real world today for talking about this type of stuff. And so we're first going to talk about wildland fire and forestry protection, mapping and documenting controlled burns. And I really want to focus on two applications, and that's going to be first perimeter mapping and then pre-planning. And I guess on the right, really quickly to give you an idea, on the right, we have a actual Ortho Mosaic map. So this is a little bit of a snippet screenshot of a training exercise that I participated in, where you can see there's smoke coming off bales of hay that were that were lighted up, and this was a training exercise for a wildland fire situation. And this is an actual Ortho Mosaic, and you can see that there's smoke. Pix4Dreact Special, it's one of the first softwares out there that can map smoke and map water. And so, Derek, can you kind of talk about how these maps come in handy when we're mapping perimeters and for wildland?
Sure. Thanks, Angad. First off, I'd like to say that this technology is so new that in the old days, as you've kind of already mentioned, to be able to go out and map a fire or any type of major incident is going to take quite a while to actually produce that map. And as everybody knows, emergency management and emergency services, is of the essence. It's a priority to us. And so in order to get this real-time information immediately increases value tremendously, right? I can tell you for one instance, my parents actually lived in an area that had lots of brush and they had a wildland fire there. They evacuated the entire area. So all the residents need to leave. And in those conditions, you know, my parents went for over 2 weeks of whether or not trying to figure out if their house was still standing. And the reports didn't come in for quite a while. So one of the things we can do is do a map of an area that's been evacuated and be able to determine whether or not structures are still standing. You know, that's a major thing that we can share that information to the citizens, and our IC would be able to convert that information and give it to ground crews. So that's a really awesome ability. And then the other thing is to be able to notify ground teams on the ground of where escape routes are or where the fire is going. So there's multiple cases and multiple situations that we can give that will help our firefighters on the ground.
Absolutely. And, you know, a lot of times in my day-to-day, speaking with different departments or going out and doing presentations out there for the community, I'll get, you know, sometimes folks that aren't as, you know, in the know, they'll say, hey, aren't fire departments just using helicopters to, you know, identify which structures have been burned, which structures have not been burned, or maybe identify where the fire is going? And wouldn't they just use helicopters? Why are drones so important for this? Why are we talking about drones here?
Yeah, well, a lot of people don't realize that the majority of the departments, fire departments nationally, don't have airships, right? They don't have air ops, and so they're limited to what they can do and those resources. And even in a major fire where you do have air ops, you know, those aircraft are taxed, and they need to be everywhere at the same time, and you're unable to do that. So to be able to have this technology and put a drone up and gather the information and share it, any department nationally could acquire this technology. And now you have the same ability to be able to, you know, gather this information and share it with the IC. And even departments that have air ops or aircraft, you know, we're not replacing those by any means. Like I said, those aircrafts are taxed. We're just augmenting the ability to give more and more information to the ground crews and the IC.
Yeah, absolutely. And, you know, I totally understand live streaming is so powerful. I think a lot of firefighters, and initially when they get into this, they're like, man, we just want to be able to get that air asset in the air, get the drone up there and look at a live stream, maybe toggle between the thermal and the regular views or the RGB views so that we can see where hotspots are. With a tool like Pix4Dreact, where you're actually producing a map, I think the story that you shared about, you know, your parents' house and having that get evacuated, here with Pix4Dreact, you can export a PDF report. And so you could theoretically share that, right? I mean, we could export that PDF report of what that map looks like so that folks could actually see what the on the ground looks like by having a quick report like that. And I guess, Derek, can you talk more about, well, let's go on to the next slide here and let's talk about a real, this is a real application, a real map. On the left-hand side, we have the pre-flight in the map, and on the right-hand side, we have the post of a prescribed burn, and you can see where the smoke is kind of going in the map. Can you talk about why that's important on the bottom hand side of the screen?
Well, sure. So to have this aerial advantage is huge, right? So we're able to see the direction of the wind, the direction of the fire, and where the smoke's going. We're also able to evaluate and figure out if we have any structures nearby or anything that may be in danger. But you know, you're able to actually get a good aerial view of the fire and to be able to understand what it's doing. Also to warn ground crews that are on the ground of, existing hot spots or flare-ups that may happen that's, behind them. And also brush crews can put a drone up and be able to understand the terrain around them to be able to decide, where is the best escape route to get out and get away from the fire. So there's multiple reasons and multiple cases that this is just really great information and technology to be able to use.
Yeah, I really like the idea about escape routes. I mean, I think drones add a lot of, safety capabilities and increase the level of safety overall for firefighters down there, working really hard. And one story that I like about this particular map that we're showing on the screen is, Derek, can you kind of talk about how the previous method of, so a lot of times when I deal with fire departments, they're always telling me that when we do prescribed burns to do good land management practices, the media or their command will always ask them, how many acres did you actually burn? Kind of what's the traditional method of figuring that out?
Yeah, so the old method is to walk the perimeter, right, and get an idea of where that fire was and where it burnt, and then try to do an estimate of what that looks like. And I know where you're going with this because React, you're able to actually fly the map, do an aerial or an area measurement utilizing the little dots that you put on your map to go completely around the burned area and do a measurement of that area. It'll give you exact measurement. So not exact, but it's very close and probably a lot more accurate than the way we used to do it.
Yeah, absolutely. And I think the increase in speed and the increase in safety of not having folks having to physically walk around the entirety of that perimeter and then being able to distribute a map like this in a PDF report to the media or to your command to demonstrate what happened on the scene. I get a lot of positive feedback about that from folks out there in the field. So I appreciate you sharing the old method of doing that, Derek. Did you have any last comments on kind of utilizing this for wildland applications?
Just also, to be able to identify where the ground crews are. So, like one company, like an engine company, could be down on the ground fighting fire, right? And you have another company coming in or rolling in to help them with that fire. Well, it's hard to identify where exactly they are or if they're in a dangerous area. So for the IC to be able to direct companies to specific areas to stay out of harm's way is of huge value. So that's probably the last thing I want to add on this one, but just that's a really major ability there.
Yeah,
And also, just to add there, we talk about using React as a force multiplier, not having to have people walk around the perimeter of a prescribed burn, but instead just use Pix4Dreact is a great example of that, because now you're not tying up personnel and you can deploy them elsewhere.
Yeah, absolutely.
Awesome. Thanks, guys. So let's move on to search and rescue here, which is, there's a lot of articles out there about search and rescue and using maps with drones, and it's definitely one of the most powerful applications. I mean, I want my own local police department and local fire department to have drones because of this very use case. I think this is one of the most, innovative ways that drones are being utilized is for SAR. And so on the screen here, what we have is just a coverage map. It's the grid mission, and kind of from the official Pix4D message, before Derek kind of talks through a common technique of how we're using Pix4Dreact for search and rescue, I want to just put it out there officially from Pix4D and from my perspective that a lot of times in search and rescue, you don't need to make a map. I think people get hung up. They're like, let's go ahead and make a map, and that can take away from the immediate application of looking through these photos. What I think Pix4Dreact can really be used for in search and rescue is that after you fly a grid mission, kind of just, flying the grid mission, getting the total coverage of the area, just doing coverage analysis to see if you actually flew the drone everywhere you wanted it to by using this very first screen where you plop in all the images and all the blue dots show exactly where all the images are. You could just see if you missed a strip of coverage because you can add multiple flights into this first screen. So I just wanted to put that out there because I'm not trying to propose that we use maps for every search and rescue. I'm just saying that this is a very good, useful feature that has been utilized for search and rescue applications to do coverage analysis, but I don't want folks to think that they should be looking through maps all the time. You really should be looking through the original photographs. So now I'll turn it over to Derek, and just can you kind of talk about search and rescue with Pix4Dreact and drones?
Yeah, on God, so thank you. And there are multiple methods to actually do a search and rescue, right? I mean, we can use thermal cameras, we can use zoom cameras, we can do photogrammetry, and there's so much we can do. And flying a grid is another way of doing it. As you know, like arson and where you have a crime scene, to do the investigation, they grid off the area and they have somebody go in methodically and search every square foot of a specific area of the field, right? So as the drone's flying this grid, it's actually taking pictures of the entire field or whatever area you're recording. And one of the methods is to take that SD card out of the drone after it's all done and separate the pictures and have people go through each photo individually to verify that what they're looking for is not within that photo. And then, so that's one method. The other method is to fly the entire grid and produce the map. Now, we weren't able to do this in the old days with the older technology that took 12 hours to actually get back, right, to produce. So now with Pix4D, we're able to actually fly that grid, do that map, and go through and have a map ready to go within 15 or 20 minutes. And now we can go through and blow up specific areas and look and discover what we're looking for. And so the other part of that is that, you know, you get different types of resolution, and what kind of resolution do you really need to do a search and rescue? You're just looking for something. You're able to verify it later, but you're able to find it on the map. And if you need better resolution, you could always fly at a lower altitude at a slower pace and get better resolutions or DPI per square inch, right? So those are just some of the methods that we can use to, but Pix4D being able to do a quick map really is a game changer as far as doing search and rescue, developing a map.
So how high what would you recommend, like, how high would you usually fly? What's your go-to, Derek?
So that's a good question, and it really also depends on your aircraft, right? If we're using a Phantom 4 with a 1-inch sensor, a 20 megapixel camera, and a global shutter instead of a rolling shutter, we can actually fly a little higher and get better definition or DPI within that image. If we're flying something else, you know, we might want to fly a little lower. And I would say to all agencies out there or public agencies that are trying to do search and rescue, they need to understand what an image looks like at a specific height. So you need to go out and practice flying, get at 100 feet and see what a victim looks like on the ground in a field at 100 feet. My recommendation is depends on the size of the area that you're flying, but I would recommend starting at 100 feet as long as you don't have any obstacles in the way. If you have trees and power lines and things like that, you might go up to 150 feet, but it really varies based on your obstacles that are around you, what type of aircraft you're using and things like that, even the time of day, because if it's lighter or dark out makes a big difference on what your image is going to look like. So to answer your question, honestly, it's anywhere between 100 and 150 feet based on your environment.
Okay, so that's still pretty low. That just to get a lot of detail in those images and really make sure we're not missing anything on the ground and we can do our due diligence. But it's definitely way faster to utilize, you know, a drone than having a ton of people go out there and do a line search. So thanks for that, Derek.
Absolutely.
Do you think there's anything else specific with search and rescue with drones? I really appreciate your comments about thermal. I mean, thermal is so powerful, especially with that Enterprise 2 dual. To be able to use those thermal sensors, especially at night, differentiations of heat, you know, and I think that's really powerful technology. And it would be my personal hope that all fire departments and all police departments have at least one thermal sensor in their repertoire, just so that they can utilize it for that application.
You know, that's a great point, Angad. But what I try to tell departments all over whenever I'm talking to a public agency is, you know, it's great to have a universal set of tools in your toolbox, because you may need that thermal camera or a Z30 zoom camera to get what you're looking for, but you also need to be able to map. You also need lights at night. You need all kinds of different equipment, right? So it's important to understand where all these tools fit in, and to be able to add react to that toolbox gives you even more capability to do more things. So, you know, like you were talking about earlier, the Matrice 210 with the Z30 and the XT2 camera, great scenario, one of my favorite setups to go out and actually do search and rescue. But I would never consider just having one tool in my box when it comes to saving lives and property. I think it's extremely important to understand what all your tools are and how they work and what they do and when to use them and how to use them. As I was explaining earlier on understanding your heights that you need to fly at to capture what you're looking for, right? So those are things to grab these tools, go out and work with them, learn them, understand them, and when you need to use them is really important.
Yeah, no, I definitely agree, and I think this industry, like Derek, folks like yourself, and there's so many others out there that everybody's so committed to just giving people the most honest, truthful answers and sharing their stories, and I think that's how we're gonna grow this industry overall. So I appreciate that. Thank you.
You're welcome.
So let's go on to this, natural disasters, post-disaster response and logistics, and how important is it to have a real-time map and like compare it to. So here on the screen, we're looking at on the left is these are maps from the Bahamas post-Dorian. So different groups, including agencies like AIRT, Airborne International Response Team out of Miami, and Global Medic, which is an amazing humanitarian group that uses drones out of Toronto. They go around the world and they used Pix4Dreact extensively here after Dorian, and we'll use Dorian as a use case here, where for the first 30 days after Dorian hit the Bahamas, different agencies used Pix4Dreact as well as different types of drones to fly and collect high resolution maps of what that scene looked like, give that to the Bahamian government, give that to incident responders and ICs on the ground so that they had an understanding of what the scene looked like. And I guess one of the most obvious things is on the right here, we have a Google map or a satellite image, and on the left-hand side we have an up-to-date map. And I guess, Derek, kind of how have you seen that drones and up-to-date maps are changing the way that fire protection is doing its work as compared to utilizing satellite imagery?
Well, in a natural disaster, reconnaissance is a major key, right? Being able to get a better understanding of the extent of the damage, right? And structures, the ones that are fallen and the ones that are still there. But there's many aspects of this. So being able to understand what structures are still standing, that's important. But then we get into different things like Hurricane Katrina, right? These buildings are going to stand, 2 days later after the building's gone down, it's still nothing changes. But what happens during an emergency is you may have people on the roof in a flooded area, and again, time is of the essence to be able to go out and perform these rescues. So my point is by utilizing this technology and flying a drone, we are able to establish and find victims on roofs, people that are trapped on a roadway, maybe in a flooded river somewhere. We're able to go out and identify what that looks like. Like I said before, the air ops, they're going to be taxed in these areas, right? They're not going to be able to go to every area and be able to establish reconnaissance everywhere. So to have units out there in different parts of a disaster and be able to put these up and get a quick map of what they have is a great way to get that information.
And just to add there, I think that this image is a really powerful example of how much more appropriate it is to use drone maps over satellite imagery, because it's showing, one, how much more resolution is captured, and also it's showing how things can change with satellite imagery, with those images being sometimes 5 years or more old. Things can change, so you're not necessarily looking at reliable data.
That's a great point, Mark. And also, in an emergency, we want to know what's changed in the last 2 hours, not what's happened in the last 2 years. So it's really, really critical and important to be able to gather that information, everything that's changed within the last 45 minutes, right? So we're able to do that now.
Yeah, absolutely. No, I definitely am a big proponent. I mean, I used to utilize a lot of satellite imagery before I entered the drone world. And yeah, satellite imagery is amazing. It can cover extensive areas of land. But I think with this technology, with having a low-cost drone with a low-cost software, you can make maps when you need them at your own pace and get the data that you need to do your job most effectively. And I think that an image like this really just does demonstrate that. I mean, so here now we have one of the features within the software, which is a Pix4Dreact Slider bar, where you can actually just compare the base map of this satellite imagery to the Pix4Dreact map on top. And you can see that there's far more definition. The buildings are a lot more clear. But also what's really interesting is, Derek, when we were going through this yesterday, you had an interesting comment about the car on the left-hand side next to the house. Can you just talk about that?
Yeah, so again, you can't use a map that's going to take you a long time to gather this information and be able to have real-time information on what's happening. To be able to see that car from this height, and it looks like we're pretty high here, right? We're able to identify that car. If that car was in a river or stuck in a gully somewhere, we're able to identify that also. And there's no way to go and do a reconnaissance on these large areas and know where everybody is when you have hundreds, possibly hundreds of victims out there, right? But to be able to identify these kind of details at this height is very valuable.
Yeah, you're right. This does look really high. I think the map here has actually been flown at 400 or maybe even a bit higher, 500 feet of elevation with a drone, because that, typically if you fly at 100 feet, like you were saying earlier, Derek, you're going to see that car really clearly, and you're going to be able to tell what kind of model it is. You'll be able to see if it has a roof rack or not a roof rack. I mean, and at 100 feet of elevation, flying a lot of these drones out here, you can clearly see maybe just a shoe on the ground almost, and clearly this map is a lot higher. One thing that I really like about this particular feature here is we're looking at the tarps. And one of the things that was important, in the response for some of the tornadoes in Dallas, and in the response that, when I talk to some folks at the Army Corps of Engineers, what they like to talk about a lot is tarps. And we're trying to see with, we fly drone maps and we see, hey, how many of the buildings, how many of the roofs that are blown off need tarps? Kind of, Derek, can you talk about where the tarps come in and how being able to quickly identify them with drone maps is useful?
Yeah, so there's a couple of different things here. So during a hurricane, people are going to lose the integrity of their roofs, or maybe have holes in their roofs, or maybe have the entire roof pulled off. Obviously, the tarps are placed there to keep any more rain or water or damage coming into that structure. But so we're able to identify where those structures are that have damage, but also maybe take an inventory of how many tarps we have in a specific area. So you're able to see, gather a kind of a soft estimate of how much damage in a specific area that you are in. So the tarps, we can see there are people probably there trying to, protect themselves from the rain and covering their roof.
Yeah, I think that, some of the stories that I heard from some of the folks that were down responding to Dorian, they're saying, hey, we're flying maps, and then we're seeing, okay, how many roofs have tarps on them? What roofs do not have tarps on them? Then using Pix4Dreact, we just click on all the roofs that don't have tarps, get the GPS coordinate, then we give that report to the incident commander, who can then dispatch services to go out and get folks to go put tarps on the roofs that need them. And then the next day we can actually just fly it again and confirm if all of the properties that need tarps have them. And then you can also see progress as over time you can go fly it again and really quickly process and see, hey, how many roofs have started construction back on them? How many tarps are we getting back? And then something else here at Pix4D that we're excited about is we're starting to collaborate with other industry partners to see if in the near future or sometime in the future we can have artificial intelligence or machine learning algorithms that look through a map and count exactly how many tarps are out there, be able to give that number to the folks that are responsible for managing those resources, and kind of just make this even more innovative technology and even more reliable for folks on the ground. And so that's kind of one of my last comments on this particular slide. Derek or Mark, if you guys had anything else about using drones for natural disaster response, just let me know.
Sure. Yeah, just to add, I mean, the tarps is a great example of how agencies can use React to most efficiently use their own internal assets, because things like tarps, they have a finite number of, and they want to deploy them most efficiently. They want to be able to ensure that they've covered the areas that need to be tarped, that they've collected tarps back at the end if it's appropriate. So this is just one example of how using React helps agencies like effectively use all of their own finite assets. And I'm sure that in a time of a disaster, these assets get spread really thin, and having a system to keep track of them is probably extremely beneficial.
Yeah, absolutely. So Derek, unless you had any last comments, you think we should head into Q&A?
Yeah, absolutely.
Awesome. I really appreciate, the content that was delivered so far. It's just tools like this are making, day-to-day jobs a lot easier and more efficient. So I'm a big fan of this type of technology. So I have a couple questions here from folks out in the audience, and I'll just I'll read them out one by one, and then we can go ahead and discuss them as a group. One of the questions is there a plan to release cloud-based React solution? Well, I guess that one's directed at me because, you know, I'm the Pix4D guy. So right now we have cloud solutions. We have Pix4D Mapper in the cloud. We have other cloud solutions that you can utilize. Pix4D React is designed to be a desktop-based solution where you can process very rapidly on the desktop, low-powered computer in the field itself. And I think that having a cloud fast mapping solution would kind of, it would go away from what the core application is, and you know, in situations like Hurricane Dorian and in situations where you're dealing with wildland firefighters out in the middle of nowhere, having that connectivity to the internet to push full resolution imagery up to the cloud and process on the cloud is not the most ideal. That's something that we've learned over time, especially from the California wildfires, and learning that who cares if you're flying all these awesome drone missions if you can't get the data to the person who needs it immediately. And so that's why Pix4D React is purely a desktop-based solution. Now, of course, what you can do is we can allow you to have sharing tools and analysis tools on the cloud with other licenses at Pix4D, and then you can take your produced maps and you can put them up into the cloud to share them with other stakeholders. So that's absolutely a solution that is available. Another thing that we've seen very common with some Office of Emergency Managements is they buy Pix4D React, they process the map, and then they upload that processed map onto their Esri, you know, ArcGIS or ArcPro or license, and then they can have maps of different areas in their town all managed within one GIS device. So thank you for that question out there. Now, another question we got is, any way to counter trees with aerial shots to help in fire logistics? Derek, I think this one's for you. Can you talk about flying around trees and aerial shots, etc.?
So to do what? To avoid trees, or I don't understand the question.
I think they're referring to, is there any way to, yeah, maybe to avoid trees, or is there anything that aerial shots can help with trees?
Well, obviously you can get an understanding of tree health and things like that by getting in large areas and being able to map those, you know. As far as, I don't really understand the question fully, but I think that in order to avoid trees while mapping, you obviously want to get a measurement. You can use your drone to do it. Just fly the height of the tallest tree and then look at your screen. You're going to identify what that height is, and then fly 20, 30 feet above that, right? So if that answers the question, I hope it does.
Yeah, actually, I do the same thing, right? You start up the drone, see the tallest area, the tallest tree, fly the drone to that location, look at your screen and say, oh, it's X amount of that height, and then you go ahead and land it down. And then you go ahead and plan the mapping mission. That's something I do the same thing, Derek. That's a really, really good piece of advice.
Hey, I'll also comment on that first question about being able to process in the cloud. And that goes back to having, you know, the most amount of tools you possibly can in your toolbox, because each one of these things are doing different things, right? If you're going to use Mapper, that's survey grade quality, and it's a higher quality that you're going to produce and go, it's going to be processed in the cloud. And then React is an emergency process, right? That you're going to get information within 15 or 20 minutes. To be able to have both of those is powerful, right?
Yeah, absolutely. No, I think that is powerful as well, and it definitely makes sense, right? And that's why, from our standpoint at Pix4D, we want to make sure that all of our data is interoperable with other sources, with other tools, because we know that Pix4D is not the only tool that, you know, firefighters are going to use out there. You guys are going to have Avenza maps. You're going to have our ArcGIS. I'm starting to see other tools come in as well, and you're using Pix4D React or a Pix4D product to make the maps from the drone imagery, you have to be able to share that data with other tools and be able to load it into other tools. And I guess that comes into another question where actually somebody has highlighted an issue. They've said that Pix4D React, sometimes the outputs are very large in size, and that can absolutely be true. Sometimes the output, the maps, I mean, if you fly, you know, 25, 30 acres of land, and that's 700, 800 photos, depending on how high you fly, you're going to have a lot of photos, and you're going to have all those photos compiled into a very high resolution map that's a big file size. And so I just want folks to know out there that in Pix4D React, before you press start processing on the screen, on the bottom left-hand side of the Pix4D React desktop window, there's a settings button. And you can hit that settings button and you can tell it exactly what file size you want the output to be, and it will adjust the processing to make sure that you only get the output size that you want. So for example, we know that a lot of wildland firefighters are using Avenza maps, offline map services, and I've spoken extensively with the folks over at Avenza, the great guys over there. And for some of the devices, if you're not using a very powerful smartphone or a powerful tablet, you can't upload a 150 or 200 megabyte map, or sometimes even a gigabyte map. So what you can do is you can tell Pix4Dreact, hey, I just want my map to be maximum of 30 megabytes on the output, and then it will produce that map to be 30 megabytes, and then it can go ahead and output it. Does that, Derek, do you have any comments on interoperability with other third-party systems?
No, I don't. I just like the fact that you can actually fly using, hang on a second, flying any software. You can fly the map and then process it with React. Sorry about the background noise there.
No worries. Thank you, Derek. Okay, that's great comment. And then another question we got from somebody out there is, can React ingest data from multiple drones, or how does it handle changing batteries midway through the mission? Derek, can you talk about flying missions with multiple batteries? How do you do it?
Yes. Yeah. So I mean, I love this part of the software that you're able to.
No worries.
Sorry again, I'm at work here. So it's a great ability to be able to continue a flight. So if you have a large map, your battery life is going to go at 15 to 20 minutes, right? So if the map's going to take you 30 minutes to fly, you're able to start your flight, and the map will go up in the air at the set altitude. It'll start its grid, start taking its pictures at its overlap. And as the battery goes down, if you get down to 30%, it's going to want to land, and it'll stop its mission, come back home, land in front of you, power down the aircraft, take the battery out, put a new battery in, and hit continue. The drone will actually get up and go to the place where it left off and continue its map, which is, to me, a great feature and makes mapping so much easier to do.
Yeah, absolutely. So Pix4Dreact Capture, that's our free flight planning application to fly the missions. That has that feature built in. Some of the other apps out there also do it, where you just, it flies whatever it can. The drone comes back home. You press resume mission, it goes back to where it left off, and it starts off again. And then you can import as many different photos into Pix4Dreact as you need. So let's say that you flew 5 or 6 different batteries or different flights, and then now you had like 1,000 photos. You can go ahead, load all those 1,000 photos into Pix4Dreact from one drone, from one camera model, and process it all together. Currently at this time, Pix4Dreact does not support processing from multiple different drones in one project. You can do that in Pix4Dreact Mapper. That's our flagship solution, that more engineering-based, high-level solution. But within Pix4Dreact, if you want to process, multiple flights, they all have to just be from the same exact drone camera, and that'll get it done successfully. And then, Derek, we had a question from the audience in regards to what happens, how do you really take advantage of using drones when the fire perimeter has moved into a wooded area?
Into a wooded area, meaning we have obstacles? Is that what they're asking, like trees?
I do believe so, yeah. So like, let's say that it was in a field, it was moving through the field, and then we entered into the woods. So from my perspective, I mean, you can see the smoke coming out from the fire line once it's moved into a wooded area, and Pix4Dreact would able to make that into a map. But just in general, have you ever had that experience?
So from my understanding, the question is so you're flying at a specific altitude and height to gather information from the fire, and then the fire continues to spread to a wooded area. Well, your first map that you set that you're going to fly is going to be a specific area to handle the lower obstacles. And then you may want to fly a second map if you're getting into a burned area, like a wooded area or a forest, and you know that you need to raise the altitude of your map, then that's what you'll do. You'll just fly a second map at a little higher altitude to gather that information.
Yeah, absolutely. I would say the same thing. I mean, you just want to know how tall the trees are. Let's say that the trees are at 200 feet. That means that maybe you want to fly the whole thing at 250, or fly the first mission at 150 feet, and then the second mission over the wooded area at 300 or 400 feet, just a lot higher than the trees themselves. And one limitation with photogrammetry is that you're only going to be able to see what the images can see. So if the images see smoke coming up between the trees, then in your map, you're going to see the top of the trees and you're going to see smoke coming up between the trees. And that's how you're going to be able to track the fire line. I think if in the future, we're thinking about how do we produce infrared maps or thermal maps. They're actually incredibly difficult to put together. Working with the folks over at FLIR to do that. You can make thermal maps in Pix4D Mapper, which is our flagship solution in React, not yet. And from there, maybe in the future, we would be able to fly with the thermal cameras and then be able to kind of see the heat signatures coming from between the trees. But right now, you can only see the smoke that's coming up from between the trees. And then we got another question here, and I think this may be one of the last questions that we take today, but all other questions we're more than happy to answer. Send me an email or shoot out an email to Mark, and Derek will be able to answer. And this last question is going to be, actually the last question is related more to collision reconstruction with drones. So maybe I'll handle that directly offline. But I think, yeah, I apologize about that. But you guys want to address it now? It says, what should the ideal photo capture settings be for mapping a vehicle accident venue? And they want to be able to see the number plates or the actual the license plate itself of the vehicle. Well, you got to fly really low for that one. You fly at 60 feet. Yeah.
Yeah, and you're going to have to fly low, slow, and you're going to have to fly a 3D map, right? I mean, how are you going to see a license plate from directly above? So that would
I would Sorry, Doug. Yeah, I would agree. That's when you're going to need to introduce not only the nadir images captured by React, but also oblique images that you could capture with something like Pix4D Mapper.
Yeah.
The other thing I would add to that.
Yeah, sorry, go ahead, Mark.
The other thing I would add to that is a lot of these DJI drones, they'll have camera settings like 16:9, 3:2, 4:3. A lot of people are just living on the default 16:9. But when it comes time to really capture high resolution images like a license plate, that's when you want to go into your camera's camera settings and make sure you're on the highest resolution possible. So on a Phantom 4 Pro, that's going to be 3:2. On a Mavic 2 Pro, that's going to be 4:3. Stick away from the lower, smaller sensor options like 16:9.
I think that brings up a really important last point, and I think we'll end it on this one, and that's that training is super critical because this is a new technology, this is new stuff, and it's very clear that the market is going to adopt drones. It has been adopting drones at a fast rate. We're going to see almost all the fire departments out there move towards this technology over the next few years because of how beneficial it is, how much it increases safety, how much it increases efficiency. And with that, that's where folks out there like Derek, like myself, like Mark with Enterprise UAS, and DSLRPros can go ahead and provide training and answer those questions and give you the one-on-one attention that folks out there need. Because quite frankly, there's a lot of stuff to learn, but there's a lot of people that have been spending the last few years to pay attention to all of this new material and figure out how it works operationally. And I think now with the new decade here in 2020, we've kind of moved beyond the early adoption phase of drones and we're moving into the mainstream adoption phase. And with that, I think I just wanted to say thank you to everybody. Please feel to reach out. We'll answer your questions. And Mark, off to you.
Okay, thank you very much, OnGod, and thank you, Derek. Just a couple of quick reminders for everyone. Everyone will receive a link to the recording, including a free React trial. So make sure you keep an eye out for that. You can reply to that email with any questions that you have regarding pricing or the new packages that we introduced today. Another quick reminder, please join us for our next webinar on May 12th, which is 2 weeks from today, to learn about the role of thermal drones in public safety. We'll have an expert panel of firefighters and police officers, including the legendary Derek Ward, sharing their firsthand experience using thermal drones for public safety. And if you're curious about that, you can find more information on our social media pages or at DSLRPros. The last thing I want to say is we at DSLRPros are really excited about Pix4D React. We think it's an extremely powerful and relevant solution, and we appreciate you taking the time to learn with us today. Thank you, everyone, and have a great day.
Thanks, Mark. Thanks, OnGod.
Yeah,
Thank
absolutely.
you.
Thank you so much, Derek. Thank you, Mark.